Before we begin, a quick question. Were you aware there was an earthquake last Saturday?
Really?
Yes. A bunch of us were at Hacker Dojo when the earthquake happened, and it is the beauty of this place that we looked at each other and kept asking, are you doing something that is making the ground to shake? First up today we have Bob. He's written 3 screenplays and 3 novels. He's also written 4 engineering books, and all of the books have won awards. He has degrees in physics and electrical engineering from Stanford and Cornell, and he also won the Outstanding Engineer Award from IEEE. Now he is working on something called SynthOS, and normally I would say this is what SynthOS is, but his introduction has taken up so much time he has to introduce SynthOS himself. You have the con, Bob.
Sure, thanks, Sophie. So thanks for having me. I've got 5 minutes, so I'll try to get everything in there. The first thing I want to get in is if you see the website at the bottom there where it says synthosonline.com, that's where you can go to use our tool for free, the Synthos tool. So basically, Zeidman Technologies wants to change the way hardware systems are designed, specifically Internet of Things systems, to make it software-centric. Instead of what you normally do now, which is to get an operating system and then build all your things around the operating system, build all your applications around it, our system says we synthesize the operating system. You put in the source code and something called primitives that look like function calls. Can everybody see it okay? So, and then you put in a configuration file, and then what you get out is pure source code, C-level source code. Even your operating system is done in C. We decided to do a demo on a robot. Igor here has created a robot system. He built the robot from a kit, but had to do a lot of modifications. Built the entire software using Synthos. It has all these tasks on it. There's different kinds of tasks called loop tasks and call tasks, which you can talk to me offline about. But he builds the task, no operating system. Then our tool, Synthos, goes through, modifies your code, puts in mutexes, semaphores, message queues, buffers, and builds the scheduler to work exactly with it. We call it an application-specific operating system. It's specific to your application. No 2 systems are going to be the same. And it does it algorithmically. It's not modules that it pulls in. It does it through algorithms that examine your code and figure out what it's doing and what the operating system needs to do. It's really easy to learn and use, a 19-page user's guide. There's 5 primitives. There's 5, I had 10. It's 5. Some operating systems have 120, like Linux I think has 120 APIs you have to know if you're going to interface with it. We have 5. Then you push a button, you get an optimized operating system. There's my contact info. I don't know where I am on time, but what we figured we'd do is afterwards, come on up and we'll have the robot running, and you can see how it does wall avoidance, uses an ultrasound sensor, and it's got LEDs and it's got motors that run independently. Thank you.
Do we have any questions for Bob? Tell us a bit more about SynthOS. What got you started?
Well, I can tell you the thing that got me started. Is there anybody here from Apple? Or who worked at Apple? Or are you at Apple?
I was a contractor there.
So you were a contractor. I was a contractor there too. I was there in the days before right when Jobs came back. It was the internet days. Nobody wanted to work at Apple, if you can believe it. And we were putting together a scheduler for the flat panel display. In fact, if you've got a Mac flat panel display, my code is in there. And we hired someone, I helped hire someone, to take over the project who just kind of kept putting in infinite loops. He kept putting in loops that would wait for resources to free up. And he didn't set mutexes, he didn't check mutexes, and so the thing would hang. And I got really frustrated, and I thought, boy, if I could just automate this, then I wouldn't have to teach people how to do this. And this is a pretty smart, sophisticated programmer, which is why we hired him, but he just couldn't get it. And we spent a lot of time debugging the system. So I figured, that Synthos would be a bunch of macros. And as I started writing it, I realized that macros just weren't sophisticated enough because it's kind of like time and space deterministic macros. In other words, you know, a macro, when you put in a macro, it's just got, you know, wherever it is, it's the same code. But the kind of macros we needed basically change depending on where it was, you know, where you're putting them. So that's what the primitives are. And then it took a much more sophisticated system to figure out how to set up the message queues, mutexes, semaphores, and how to create the scheduler. And that's the kind of stuff that Igor, he came to me working on something similar, and now we're working together, and he's the one who's taking this, and we're really expanding it. And I'd like everybody to join us on the cutting edge. You know, that's why it's free. We really want you guys using it. We think this is the future of software development, and we want to get your feedback on it.
Thank you, Bob. One last question, since we have a few seconds of time. What did you do when your C code was compiling?
What? In the old days, you mean? I used to watch, you know, we had, at Apple, we were on the video, on the monitor.
I was just heckling you, man.
No, you know what we did? I'll tell you what we did. We used to test it with video. I saw Terminator 3 like 500 times because we had to make sure the video stream was correct. So if anything was compiling, I just watched Terminator 2. I take that back. Terminator 2.
Well, thank you, Bob, and we hope you will be back.
Okay, thanks.
Next up, we have John. If you could start setting up, please. John is our computer vision person. If you see a robot chasing somebody here, that person is John. If you see somebody chasing a robot, chances are that person is also John. He's also an incredible human being in that he keeps leaving parts for people to make us.
Yes.
We can say with some certainty you are not an alien or number 5.
You did ask me that as a hypothetical question once.
If anybody of you have any hardware questions ever, come to John. He will be happy to help you, and he will know the answer. You have the con, John.
Thank you, Captain Janeway. Right both times. Hi, I'm John. I like to make cool stuff. I currently focus on iOS apps using computer vision. I do a lot of Bluetooth LE stuff too. A couple years ago, I joined this Kickstarter, which for the Pebble, which is the first actual real working smartwatch. Some would say still is. And you know, a year later, my Pebble watch showed up, and I wanted to write watch faces for it. Unfortunately, it had a video problem, and I was moving. So by the time we went back and forth, all the easy watch faces had been done for the Pebble. So I had to ask myself, what would be really cool? This is a rhetorical question. I had a rhetorical answer. And of course, that would be the two-way wrist TV. I can only do one way here. But I thought that would be a really cool thing to do on a Pebble. And the only question was, what would I do for a video source? And that really stumped me for a week. And then I realized that I wrote something that does that. I actually wrote an OpenCV app, which you can get off my GitHub repo, which streams video from the camera, runs it through arbitrary code, and then runs it out to the stream. So that arbitrary code could simply have some Bluetooth code in it that would send the video out to the Pebble. Just so people are not familiar with the Pebble, it's a 1-bit screen, has 3 buttons on the side that are available for the UI, and as a developer, no debugging feedback and no malloc. Malloc, I think, has since been added since I wrote this in the 2.0. But hey, enough of my yakking. So, there we go. Survey says.
Hey. Yeah.
So,
hey, I can see you, John.
Cool. I can see you too. This is awesome. But now comes now we go from merely regular awesome to extra special awesome. So now, Jesus, would you wave? You seeing that there? Or is it
I don't know, am I waving? My arms are moving. Charlie's arms are moving too.
Let me
Go
switch.
closer. You always.
You can see my fundamental problem here.
Yes. Do you want me to stand closer?
Yeah, why don't you come stand closer? Oh, I see you.
I don't want to get in the camera view here.
There you are. Okay.
Am I there? Can somebody see me?
Yeah. You look like a hoarder. Yeah, I can switch to a high-res mode.
On the high-res mode?
Yeah. Beautiful.
Oh, there I am. Hey.
Yeah.
No, I don't want that.
Some things are not within the realm of technological possibilities. Anyway, so that's live streaming video running off of a Pebble watch. You can either see it fast or high resolution because I get 118 bytes per Bluetooth frame. So you can either use all of them to make a very chunky picture or 5 or 6 lines at a time of a higher resolution picture. Now that would be pretty awesome in and of itself, and how am I doing for time? Cool. But that doesn't really answer the question of how do I control a robot with it? And the answer is like this. And come to pop. I would be remiss if I didn't point out to you that this was an actual commercial product, which you can you can actually purchase in the App Store. And because you're my buddies, I have promo codes. So anybody here who has an iPhone and a Pebble, see me afterwards, and I will give you a promo code good for a free copy of this app. Otherwise, it's $2 in the App Store. Thank you very much.
Thank you, John. Is this the same robot we played chase with?
Yeah.
Oh, goody. Eugene, if you could set up, please. Eugene was with Samsung, where he helped develop algorithms for Samsung's camera. He was also a senior image scientist with CSR. The first time I met Eugene, I was stuck with some C code. I was trying to build a robot and do some animation, and well, the code kept throwing weird stuff. And I still couldn't understand it, so this dude said, go stand in the corner. And he was serious. And we did not speak for 3 days because he said, I don't learn code fast enough. Eugene is working on something called HiAlgo, which is basically using software to optimize Windows gaming. But what he's demoing today is something totally different. You have the con, Eugene. And this is why people, we do hardware tech.
Yay!
You did in like 10 seconds.
Okay, so like Sophie said here.
Microphone.
Microphone. Okay, like Sophie said, I'm Eugene. My name is Eugene, and I am the CTO of a company called HiAlgo. So originally, I'm an algorithm developer, so hence the name. It's supposed to stand for high algorithms. So people often confuse the name. So just like, since I mentioned HiAlgo, the main business of our company is accelerating 3D graphics and allowing you to play your games, your PC games, better on your current hardware. But today's talk is not about that. So HiAlgo does other projects besides the 3D graphics, and this is one of them that I'm going to talk about. And today's project is about how you use your mobile devices, and in particular, one aspect of it is how many hands you need to use a mobile device. So basically, right. So basically, for example, if you need to operate a map, you can, so this is a map here. So you can pan a map with a single hand. But when you need to zoom in or zoom out, you actually need to use, so you need one hand to hold the map and to hold the device, and the other hand to zoom in or zoom out. So basically, if you're talking about an actual mobile device, so to pan a map, you can just hold it like this and operate with a thumb. If you need to zoom in and zoom out, you basically need to use the other hand to operate it. So, and that was a problem for me because at the time I was smoking and it was highly inconvenient. So I thought, is there a solution? And I came up with a pretty nifty solution, I think. So basically it will work like this. So for panning, you would use this as regular, and for zooming in and out, you would use this kind of circular gesture.
Ooh.
Well, so basically, yeah.
You're making me jealous, Eugene.
All right, that's good. So I can show how it looks on an iPhone. So this is a map, and this is me panning it, and this is me zooming it in and out. So I can choose a point, I can concentrate on it, and actually zoom it in and out. Yeah. It's pretty convenient. So there was this whole deal with patents and Samsung suing Apple and Apple suing Samsung, and one of the issues was the pinch to zoom patent, which Apple is trying to get, and Samsung and Google are feeling anxious about Apple getting it because then they'll start enforcing it. So this might be a good alternative.
What are they going to sue you?
Well, they might. I have a patent. Right. So like I said, this is this nifty presentation that says now you can so as applications go, it clearly you can use it for other things. Other things beside maps, you can use it for web browsing, and one particular application is for a smartwatch. So basically, a smartwatch has a very small screen, and if you want to zoom in and out the content on a smartwatch, you kind of use pinch to zoom gesture repeatedly. But in this case, if you just kind of keep rotating it, it's a continuous gesture. You don't need to lift your finger. So and now there is also one more thing. So actually, it turns out that I was working on this gesture, and then there's another one which I implemented kind of for completeness of the solution. You can actually rotate the map, not only zoom the map with one finger. So if you take the point that interests you and not just zoom it, but if you drag it to the bottom edge, and then you can slide along the bottom edge, you can actually rotate it. So like the case scenario would be, let's say you're somewhere on the map and you want to zoom out to see where you actually need to go, and then so you zoom in and you follow the path, and you make a turn and you follow another path, make another turn, maybe zoom out to look that you're still in the right place, and that's it. Change the scale, go to the smallest street, I don't know, something like that. All with one hand.
Eugene, I just have one thing. Smoke more cigarettes, because that was a great idea.
Thank you. Other questions?
Can you write a patch that would go with your device so that would run?
Oh yeah, just forgot the whole completely forgot why I'm doing this. I need an app to integrate this gesture into an app, because you cannot do it on a system level, because iOS is like a closed system. So if anybody is writing an app and it has a map component, I'm willing to give like perpetual license to use this thing. I want to get it out there to demo.
Without plugging it over to Google Maps.
Yeah. So, but it's going to be on the source code, and you need to compile, not just plug it in.
Do it work on Android or Windows?
Well, yeah. Well, you know.
But I mean, would you actually have the same problems with gesture integration on Android that you do on iOS?
Like system-wise, yes. Unless it's rooted or jailbroken or whatever. Thank you.
Thank you, Eugene. Next up, we have Barry. If you could step up, please. Barry was in computer systems. Then he decided bike lights were not being done right. So he's doing bike lights right now. His lights are patented, and he spent 4 years and more money than he'd care to even think about building these perfect lights, which go on sale starting September. You have to come, Barry.
Okay. Thank you. Yeah, I guess in the beginning, bike lights were just this little bulb, and then they put a reflector on them.
Microphone.
Yeah. If I can talk loud, because I'm going to need 2 hands to assemble this thing. Anyway, the thing with lights is either they're too dim, or you make them brighter and they get full of glare. You can add bigger batteries, they get more powerful. You can even make this obnoxious Google torch unstrapped. It's massively bright, but it's also sending glare all over. And it still has the same problem as every other light, especially LED lights. What's that? It's a big round beam. Your eyes focus on the bright spot in the middle, and by the time you get out here somewhere, you lose your peripheral vision. So you don't see the squirrel or the pile of horse poop on the trail or anything else. Scale that up into a motor vehicle or a cop on patrol. You don't see the bad guy in the corner. We do have Palo Alto detectives test using my lights right now. So it has to be profitable. It has to be worth doing. So here's, in 5 minutes, how to put together a Barry beam. Start with a heat sink. Heat sink is made of cool polymer, which is half the weight of aluminum but carries heat just as well, which makes the mass and the weight practical. Take a thermal tape and put it on the bottom. Get the right side yet. Put it on the bottom of the heat sink, aligned with 2 aligning pins that are molded in the bottom, so everything goes in straight. We also have a U-slot, so it's self-aligning, where most LED boards are disc or star-shaped, and you have all kinds of problems getting them square. Peel off the back of the thermal tape.
Will it make you uncomfortable if I hold the mic to your face?
Oh, that'd be great. Cool. So peel off the back of the thermal tape. Now we take a circuit board. First, we're going to flash the firmware on the circuit board, just to save time. But this is a standard Atmel little firmware flasher. First, you measure your temperature in Celsius, because we have thermal sensing on chip. Then one program writes into the script for whatever your temperature basis is going to be to calibrate. Then we put this on there. 6 quick little pogo pins. Click program. 5 seconds later, firmware is flashed. So now we put the firmware. Now we put the board. Now check this out. How do you get battery tabs to go through a board and latch in place? All real quickly. Well, one side has a step, so it'll go through the hole and slide over. The other side will bend backwards, so while this is going through the hole and sliding, this is out of the way. So push that through. Back up to the aligning pins. Slide that up. Battery positive comes over. Now you got your battery tabs rapid assembled. Let's put the thermal tape down and take our LED board and collimator. Now I showed you the U slot, which self-aligns the tape. Optical alignment is critical when you're not making a big round beam, so I designed my own board, which sits within a 0.002 of an inch clearance within the U slot. Try and find a Chinese company to make a board that tolerance, but I did. So we take the collimator, For now, this is an off-the-shelf collimator, but I have a custom collimator in design. That's the next 50,000. Seriously. So the LED board in the slot, right in there. Now I have a little tab that the collimator will tuck in underneath. Because you wonder, what am I doing putting a collimator on LEDs without any glue or adhesive? How do you hold it in place? Again, rapid assembly. So you put that in, push the board up in place. Next step would be to solder 4 wires. Developing Gourmet does, put that down. Out of the oven comes a light, all soldered in together. Now we take the custom reflector, which is made by the same company that makes all the stacked metal servers for HP, Dell, and a whole bunch of others. Place this in there. Again, the optical tolerances are pretty extreme, so it takes that level of company to do it. Put that in there. You take, where'd the lens go? There's a lens here somewhere. Take our custom lens. The edges of the lens are beveled at the same angle that the lens sits at. So on the bottom, you can sit horizontal with a retaining tip. If you cut a swept arc in the top of the housing, the lens will sit in under its own pressure. Now we take the bottom, put the bottom on there, take the screw, put the screw through the bracket, through the bottom, through the lens. I forgot the O-ring, but there's an O-ring that goes in between. Put that in there. And screw it together. So here you have one screw retaining the whole assembly, the whole housing. And in process, this also pressures the thermal tape. Now we get the battery in. Processor boots up on its own on contact without needing to get the switch. Now we take the cover, put it on, and an O-ring on there. What do we have? We have serious shock absorption here, because anything that normally snaps on is going to snap on impact. So this battery cover doesn't snap in. It can slide, it can deal with impacts, and it can handle vertical. So there we have it. Then you take it, put the Velcro through. Why Velcro? Because every little rubber belt straps break really easily. So here, this is Velcro that can't break under as much strength as any of us can put on it. Through.
This looks amazing. Thank you, Barry.
Yeah, anyway, back to the final beam. This is nearly DOT legal for federal motor vehicle use. It does comply with the German STV0 bike light already, and this is way more powerful than anything else. We also have a significant player in bicycle lighting with that has 25% market share that's licensing and partner.
Thank you. We have a not so nice announcement to make today. Jack, who's been part of the Lightning Talks team, is moving to Sacramento, and he will not be an active part of the team once again. I wanted to make sure everybody knows what an amazing, amazing, amazing person Jack is, and how hard he has worked towards making the Lightning Talks entertaining, engaging, interacting with people. You know, there are always, like, we have 4 speakers, and then 3 of them will invariably cancel 5 minutes before the talk. True story. Then we will have hardware checks. We will do rigorous hardware testing, and things will not work. And the person who's made this work so far has been Jack. Thank you, Jack, for everything you did for us. We also have a new volunteer called Anil. Anil. Hey, man. Anil has been doing an amazing job interacting with the speakers. We need like 3 to 4 speakers every week, and it is not an easy task, believe me, because everybody has commitments, and then some weeks we will have like 15 speakers, and all of them are pretty good, and all of them will insist that they go like on that same day, and believe it or not, on the same time. They want to be like speaker number 2 on Friday. Anil is a person who's been helping coordinate those things. And Anil and I have very different management styles. Like, I would send out mails saying fellow Avengers, and Anil is the person who would say, dear Sophie, and then add best regards for good measure. And for a while I was like, he's driving me crazy, but he's so amazing that I will just let him drive me crazy. We are also looking for volunteers, so if any of you think, and we have Ben, who's doing our video editing from now on. Hey Ben. If any of you guys think you want to volunteer for lightning talks, it needs a certain masochistic strain, but it is also very rewarding and good fun. Please talk to either one of us, or Wally, whose idea it was and who is the chief mentor of the Lightning Talks team. Thank you all. Live long and prosper.